In this lecture, we will take a look at some of the steps involved in writing programs. We've seen how to use the shell. We've seen how to use VI to edit files, and we'll need all of that to write programs. Okay. So this is chapter 11 in the book. And this chapter describes the essentials of program development, that is, writing programs, that custom programs that we can execute on a Unix or Linux environment. It explains the steps in the process of creating a program and provides a general description of the available computer programming languages. We'll see that there's quite a bit more that we can do than is really in the book. Okay, we go over an example of a simple C++ program and walks you through the process of writing source code to make an executable program. And we also look at the use of shell redirection to redirect the output and error messages of programs. So far we've looked at shell input-output redirection. We've looked at mainly output but not error, I believe. But in this section we will look at redirecting error messages too. Okay, so what exactly is a program? So if you've used the Windows environment, basically the program that we're talking about is the executable file. Because an executable file has machine language, and so that's what we want to end up with. We want to take whatever program that we have, eventually through a couple of different ways we can end up with machine code that we can actually run on the CPU. So the program, or the executable, consists of a set of instructions that guide the computer in performing basic arithmetic and logic operations. That's all the computer understands. It really doesn't understand things like Java while loops or Java method calls. It doesn't understand object-oriented programming, none of that. All it knows is a certain fixed set of instructions. Each instruction tells the machine to perform one of its basic functions. So each machine language instruction is very, very simple. It might just do something like this. Multiply the contents of memory location 1000 with the contents of memory location 2000 and put the result in, let's say, in 1000. So it's simple instructions like that, and even more simple things like that. Just, for example, move the contents of memory location 1000 into memory location 2000. Those are the kinds of instructions that the CPU actually understands. The operation code, or the opcode, specifies the function. So usually a machine language instruction will have an opcode or operation code and operands. And so the opcode in this case, in this example, is multiply. So there's usually a single byte, sometimes a couple of bytes, that say what the operation code is. So remember, a byte is 8 bits. So roughly speaking, 8 bits can specify what opcode the CPU should execute. So this is a simple example of a typical instruction. Almost every processor will have at least an add, if not multiply. Programming languages, on the other hand, are meant to be written usually by humans, and so it's a little bit more high level. So we'll use the term high level to indicate something closer to what humans interact with. Programming is the process of writing instructions, that is, a program for a computer to solve a problem. These instructions must be written in a computer programming languages such as the ones you've used before, like Java as a basic. Java is a high-level computer programming language. A program can be anything from a simple list of instructions that adds a series of numbers to a large, complex structure that calculates, let's say, the payroll of a corporation. Like computer hardware, programming languages have evolved through the generation, involved in generations. Each new generation of languages improved on the previous ones and incorporated more capabilities for programmers. So right now we're up to third, some say fourth generation programming languages. Okay, so at the very top are the high-level programming languages that are a lot more abstract when you compare them to machine language. So at the very bottom is machine language. That would be, I guess, considered first generation programming language. Before that, it used to be switches. You just turned switches on and off. And sometimes you might still see some of these old ancient computers. If you get a chance, try to program one of those machines. You just flip switches to write a program. Second generation language would be an assembler. And I'm hoping that we can get around to using assembly language programming. If you don't get a chance to write an assembly language programming in this course, definitely next year, if you're a junior, you'll get to take computer organization, and in that course we will use assembly language programming. So these are considered low-level languages, and above this are the compiled or interpreted high-level languages. I don't think any of you have used Fortran. You can. It's still a good language. It's a pretty old language. Similarly, COBOL, they say there's more COBOL programs than any other programming language. Pascal, it's not very popular anymore. Some of you may have used BASIC. Most of you use Java, so Java is a high-level language. It should be here. And then the other two languages I think most of you will get a chance to use. C, definitely in this course, it's very important that you learn C. You can get good at programming in C. C++ is something that we use in the data structures course. So some of you may have taken it before, or you might be taking it now, or maybe some of you will take it in the future. So C++ and C, definitely very important for computer science majors. Okay, so in the end, whatever language that you use, you have to end up with machine language instructions that are coded as a series of zeros and ones. It basically just means it's binary. It's binary data. Assembly language is sorry, the same the same kind of instructions as machine language, but they are represented in recognized symbols called mnemonics or memory aids. For example, the mnemonic mul is used to represent a multiply instruction, and add for ADD for add, and sub for subtract, things like that. And you will see this, if not this semester, next year. Okay, so high-level languages, we went through them. These are our languages that we probably won't use. C is pretty old. Now it's pretty much, I guess 40 years old. And it's based on principles practiced in Pascal programming. It's mainly targeted for system programming, which is what this course is about, creating operating systems. So if you look at any operating system that's out there right now, so that would include Windows, Linux, Mac OS X, iOS on all your iPhone and iPod devices and iPads. All those operating systems were written in C. Compilers are usually written in C. So even C compilers are written usually in C. Most of the Unix operating system was written in C. So there's a small part of it that might still be written in assembly language. Same thing for Linux. Most of Linux is written in C. C++ was developed in the 80s, the mid-80s, late 80s, to add classes to the C language. So C++ is just C plus classes, essentially. And the tools needed to make it an object-oriented language. Object-oriented programming is a big deal, especially these days. It's pretty much taken for granted that that's what you need for big programming projects. And if you want to look for a job these days, you pretty much have to know an object-oriented programming language. C++ is one of them, so is Java. Java was developed by What used to be Sun Microsystems, they no longer exist. They were bought up by Oracle. So this was before Sun was bought up by Oracle, way back in 1990. So it's about 20 years old. Originally, it was designed for use in control systems of consumer electronic devices such as TV sets, microwave ovens, and so on. Things like that, small embedded devices. Later, it was embedded into internet browsers and programs for web pages, and now it's pretty much the dominant programming language. It's the most popular, more people program in Java than I think anything else. Okay, so that's a brief overview. Basically, the idea is that you want to program in a high-level language, but you want to end up eventually with machine language code, because that's what the computer can execute. So the exact steps to follow for producing a program depend on the computer environment, basically the operating system. Windows techniques are different from Linux or Mac OS X, but the idea is basically the same. You can take all of the steps that we learn for Linux and actually use them pretty much with no changes. As long as you have the compiler, things like that, you can do the same things on Mac OS X and on Windows too. Actually, you can download certain software that mimics Unix on a Windows machine, and you can create programs just like we would on Linux. Okay, so what are the steps? Regardless of the operating system and programming language, the following steps are necessary to create an executable program. Create the source file or source code. This would be the .c program, xyz.c, a C source code program. And that's what you want to use VI for. That's I think pretty much the only thing, because once you use VI, create the source code, the source file, you'll use tools to compile that down into object code. So that's pretty much machine language, almost machine language. It's almost everything that you need to execute is there, not quite. You will take an object file and then link it with other library files and things like that to create an executable file. These two things you don't want to look at. You can't really edit them. You can if you really want to, but most people don't do that. Most people just use an editor to create source code or edit the source code, and then use tools to create object files and executable files. This is true for Linux, Windows, Mac OS X, iOS, anything. Turns out this is what the Eclipse IDE, those of you who've used Eclipse to write programs, you use Eclipse to write this, and behind the scenes, Eclipse creates object code and executable files, and then you run it. So Eclipse hides all of the details, and in this course we get to see all of the details behind creating executable files. Okay, so the source code, you use an editor such as VI, which is what we will use in this course, to write a program and save what you write in a file. This file that you create using VI is the source code usually, something xyz.c, or if it's a shell program, you don't have to have a file name extension. Source code is written in the programming language of your choice. You can even write Java programs. By itself, your computer cannot really understand it. The goal is to convert the source code to machine language or an executable file, or use an interpreter to convert code into machine language. Okay, so let's take a break here and I'll set up another video with more details coming up.